Hello everyone. Today we are going to discuss about the IP packet and its various fields. So, the first thing about the IP packet is we're gonna discuss that what does it what does it imply, the 32 bits. So as we know, the always the packet is in the multiple of 32. So my question is that why the packet is always is in the multiple of 32. It's because of the processor, because there are two type of processor available in the market. One is 32 bit and another one is 64 bit. So as 64 bit is only being popular in the last 15 years, 15 to 20 years, and the 32 bit is the processor that is available. And so for the efficient processing of the bits, it can efficiently process 32 bit at a time. So the packet is always is in the multiple of 32. Now the people will say, why can't be it in the multiple of 64 bits? It's because the 32 bit processor will not be able to handle the 64 bit at the same time, but the 64 bit processor can have the 32 bit plus 32 bit at the same time. So that's why the packet is in the multiple of 32. The next question is that what happens if the is not? Okay, every time the data will be different, so every time it's not gonna be into the multiple of 32. So in that case, we will use the padding field. This field will be used in that case. So we will just enter the dummy bits to make it the multiple of made the IP packet the multiple of 32. How we do that? So we will utilizing this field of the IP header, that is the padding. So in the padding we will just add the 32 bits, we will just add the dummy bits to make it a multiple of 32. Okay, now let's move on to the version. So version as you know is a 4-bit field. It's the 4-bit field. So values are gonna be 2 power 0, 2 power 1, 2 power 2 and 2 power 3. So it can have hold the two value, for example 0, 0, 1, 0. So this value will be 4 and this value will signify that it is a IPv4 packet. And if the value is 6, so this will imply that the packet is IPv6 packet. So the version field, the value of the 4 bits will signify what type of packet is it. Either it is version 4, version 6, it will depend on the value of these 4 bits. Either it is 4, either it is 6. Okay, so now let's come on to the header length. What is the header length? Header length, as you know, in the network layer, so we got the payload, plus IP header. So these two things will be called as IP packet. and the payload will be encapsulated into the IP header. So the header length will only give you the length of the header. Actually, the header we are adding, what is the length of it? Okay. So, and you will see that header length will vary from 20 to 60 byte in general. So as you know, the length of the header will vary from 20 to 60 byte, and 20 byte will be your normal in the normal case, in the normal scenario, and 60 byte will be when we will be using this field, that is the option. When the IP header will utilize this field, then its length will increase, the length of its header. And then the next thing is the what is the total length. So total length is actually the length of so total length is actually the header length plus payload. So if you have a total length of 100 byte and you will have the header length of 20 byte, then you can easily calculate the payload. Then payload will be total length minus header length. In this scenario, it will be 100 minus 20 byte. So it's going to be the 80 byte. For example, let's see a capture packet. I have captured a EIGRP query packet. So we are going to see it. So here is the IPv4. So in it encapsulated is the Cisco EIGRP layer 3 payload. So if we see the version, the value of the version is 0100 as we have discussed, and the header length is 20 bytes. And if you see this field, the total length, it is 66. So how do you know what is the length of the payload, the length of the Cisco EIGRP it is carrying? What is the size of it? So we will just subtract from 66, we will subtract 20, so it will gonna be the 46. So 46 is the length of the payload it's carrying. Okay, now let us move on to the other fields. Now we have discussed about the version, the header length, and the total length. Okay, now we are going to discuss, you already know the source address is the 32-bit IP address. That's a very common field and everybody knows about it. For example, if you're gonna take it, it will be 192.168.1.1. So this is the 8-bit, this is the 8-bit, this is the 8-bit, this is the 8-bit. These four fields are 8-bit. Sorry. This is the 8-bit, this is the 8-bit, and this is gonna be the 8-bit. So total the value will be 32-bit, or we can say 4 byte. Same is with the destination address. So we have also discussed these two fields. Okay, now let's move on the what is this, the type of service or the differentiated service. So type of service and the differentiated service. So total length is 8 bits. Now let's discuss this. that is a toss or differentiated service. Value is 8 bits. For example, let's say there are the 6 bits 1, 2, 3, 1, 2, and 3, and 1 and 2. So these 2 bits are used as ECN. Is used in the case of ECN. It means explicit congestion notification. So for example, if there are 2 routers and this router is facing congestion on its side, then what it will do, it will notify that with the ECN bit is equal to 110 that I am not ready. I am not ready, I am facing congestion. Okay, so how it notifies? It notified by setting last 2 bits to 11. And if we see in the case of these 6 bits are actually used for the type of service that is called the toss type of service. So first three bits determine the class of service, and last 3 bits determine the signifies the drop precedence. So what does it mean, these 2 fields? Let's discuss this. Okay, so these 3 bits is the 1, 2, and 3, 1, 2, and 3. These 3 bits will determine the class of service, in which class it belongs, and this will determine the drop precedence. So drop precedence means what are the chances of being dropped, or we can say the probability of being dropped. And class of service will determine the class. It will depend upon the value. So its value is will be, if it is 0, the value, if the 3 bits are 0, then it belongs to a routine class. If the value is 1, these 3 bits, then it belongs to the immediate class. Sorry, the packet belongs to the priority class. If the value is 2, and the packet belongs to the immediate class. If the value is 3, the packet belongs to the flash class. And if the value is 4, the packet belongs to the flash override class. And if its value is 6, that is a 1, 1 and 0, then it's belong to the critical class. Then there are also the 2 class, namely the 6 and the 7. That is the inter-network control and network control. So higher the value of the number, then more prioritized the IP packet goes. The more prioritized the IP packet goes. For example, if you have encountered an IP packet having a priority packet having the class of service 1 and an immediate packet having the class of service bit set to 2. So who will be processed first? The first one to be processed will be which will be having the higher value. So it will be processed. It will be first processed and be lined up into the outgoing queue first. Outgress queue. So first it will be taken out from the ingress queue and then it will be processed first and then it will be out from the outgress queue. So these are the things about the class of service. Higher the value, the more priority it's get. The first it will get processed by the device. Okay, so you would see the critic. So these are the class, the routine and the priority. So every class also has the drop precedence. So these are called the dip bits. Okay, so if we are going to discuss it, the dip bits. So dip bit also have value. So out of these 3 bits, the last one will always remain 0. That is reserved. And these 2 bits, the changes will come. This will have the value of 1, 2 and 3. That is, the value will be 1, 0 and 1, 1. So this will be the low, this one will be the medium, and these signifies the high. So the higher the value of the drop precedence bit, the higher are the chances of being dropped. Now, for example, you have encountered a packet having the bits like this. The let's see, 0, 0, and 0. Right. 0, 0, 0 means that is the routine class packet and it belongs to the default class. So it means it is a mango man packet. It means it will not get a special treatment. For example, your ICMP packet, the every regular traffic is the routine packet. It will not get any special treatment. So for example, if a priority packet with the value of 001 or any other packet with a value of 010 will came belonging to this class, the priority class, so it will get the priority than the routine class. The both will get priority of the routine class. So if out of these three packets, who will be processed first? The first will get processed will be the immediate class packet because it has the higher cost bits, class of service bits. Okay, and we will get processed, and then this will be processed on the first. It will be processed, and on second this will be processed, the priority class, and on third this will be processed. Okay. So for example, now let's combine these two concepts. Okay, if we combine these two concepts, for example, the the routine class will have these values 0, 0, and 0, and 0, 0, and 0. The priority class will have this value as 1, and it will have three fields, three dip bits of different values. So what it will be? It will be 0, 1, 0, 1, 0, and 0, and 1, 1, and 0. That is a low, that is a medium, and that's the high. Now if a packet came, for example, if a packet came with 001 and 010, so who will get the 001 and 100 and 001 with these bits set? So three different packet came, so who will get the first preference? Who will get the first preference? The first preference will get by these, which have the, because they are belonging to the same class, but the drop precedence bits are different. So Out of these, which will have the low value will be processed first, and medium on the second number and high on the third number. In every class, for example, if you would say in the similar thing happened with the immediate 0 1 0, again the 0 1 1 0 and 1 1 and 0 0 and 0. So this belongs to the low, medium and high. So who will get the treatment first? In this case, you have received 1 0 0 1 0 0 1 0 1 1 0. So 0 1 0 1 0 0 and 1 1 0. So out of these three packets, if a device is receiving, for example, if a layer 3 device is receiving, able to process the IP packet, so who will get the first preference? The first preference, because as they are belonging to the same class, that is the immediate class, the value is 2. So the drop precedence value, which one is having the less, will be processed first. So this packet will be processed first, this on the second number and this on the third number, if they are being received at the same time. Okay, so same thing is with the flash class, flash override. They also have these three different things: flash override and the critical. Actually, I want to discuss about the critical a little bit. So critical has the value of 6, that is 110. What does it? And it's have the value of 110, and it's these fields are 0. So whenever a critical packet comes, so there is just it is a critical packet, so we don't have to have the last like three differentiate will be processed. So the critical packet is just a critical, so it has to be processed before any of these classes packet, because critical sometimes the packet is used in the case of voice, because the voice data is time critical, or you can say it is a real-time data. So for the voice, the time really matters. So first, the priority will be given out of all of them, will be given to the critical packet. Okay, so now if we goes on to now let's the only two classes are remaining, that is network and inter-network control. So network and inter-network control, the 6th and the 7th one, so they are up to 5, up to 5 we can, it can be set by the device, means we can manipulate the packet through the device, but 6 and 7 are already reserved for the routing protocol. These are reserved, these two classes are reserved. Okay, now I want to discuss that why they are given such a high class value. Such a high class value. The thing is that they are given such a high class value is that because, for example, if you are receiving that is your end device, there is a packet coming here, and there is the EIGRP neighborship on this one, R1 and R2. They are the EIGRP neighbors. So they will be exchanging the hello packets. So hello packets they will be exchanging after the all of them get the update and the network gets stable. So they just will be exchanging the hello packet. So what? So if a packet came, you know, this the forwarding of this packet will depend on the EIGRP protocol. If the EIGRP protocol, that's why, you know, the routing table will be built on the basis of the routing table will be built on the basis of the routing protocol. So that's why the routing protocols are given the high priority than of the highest highest priority, that is a 6 and the 7. Because for example, let's say you have given the priority, your routing protocol has got the priority of 5, you have given the EIGRP the priority of 5 or another routing protocol, and the packet came with a priority of 7, you have given some other the priority of 7 or the 6. Okay, now what will happen if its buffer is being full and it can only what I can say, carry the it can only process one packet. So what will happen, the EIGRP packet will not be processed. So there may be the chances the neighborship will drop and the routing table will flush. Okay, so what will be the use of then accepting this packet? This packet will get dropped because of the routing table doesn't have an entry of the destination, as the EIGRP neighborship has been dropped. So that's why we have given the EIGRP the EIGRP or any other routing protocol, you can say, the value of 6 and 7. So if you want to see, I can show you with the same packet. If you would see the opening, the differentiated fields. So if you see, the class is 6. So all the routing protocol are belong to this class. If I want to show you, let's see the capture. So if even I have the OSPF capture, I would show you any OSPF packet. Let's open this and it will see that DSC field. You will see that even it has the value of 6. Okay, now we have discussed about the field. Now we have discussed about mostly all of the fields. We have discussed this, we have discussed header length, we have discussed type of service or differentiated service or bits, we have discussed the total length, we have discussed the source address, this option and the padding. So the field remaining is the TTL, the time to live, the protocol and the header checksum. So we are going to discuss it. So let's talk about first the header checksum. So actually the header checksum will be calculated on the only on the IP header field. The payload will be having their own checksum methods. So how the checksum will be calculated? The checksum will be calculated with the ones complement method. It will be calculated, and so every device, when it will be receiving the IP packet, as you know, the TTL field will be decremented the each time. So the header checksum will be changed on every router for a layer 3 device. So once the header checksum will be calculated for every router that will be between the source and the destination, it will change. So many people think that the router or device only manipulate uh, the layer 2 frames value. They derive the layer 2 frames and they don't change any value in the IP header, but the two value changes. One is that TTL changes, and if the TTL changes, then they have to again calculate the header checksum. So header checksum also changes. So when the device will receive the IP packet with the header checksum value, it will again calculate the header checksum, and if the value are different, again the ones complement will be the sum of one complements will be carried out. If the value is changed, the packet will get discarded because it has lost its integrity. The bits have seen some error has been included. So that's why it is used for header checksum is used for. Now if we move on to the time to live, it is in short it is called as TTL. TTL. So for example, there is a router. There is a router. So for example, your device has issues a packet with a TTL of 255. What the router do? The router will subtract 1 from TTL, and before sending it will send with the TTL of 254, and this router will receive it with the TTL of 254, and it will decrement it by 1, and before sending it to another router it will send with the TTL of 253. So it will be decremented by 1 for every router. The TTL will be reduced to 1. Okay, now the question came, so what will happen if this router receive with the TTL of 2? For example, it has received the TTL of 2, and 2 will be gone with the TTL of 1. When the router, that the R3 will process it and subtract it 2 minus 1, and it will go with the TTL of 1, and this router can process it. It will know that it has been, the value is 0, so it will issue a ICMP message of the TTL expired, the TTL time exceeded expire message of the ICMP. Okay, and even this feature is also being utilized by the trace route. You know, the trace route, it is a tool to calculate, to know the what are the hops uh, you're, you're encountering in between your source and the destination. So even trace route uses the TTL. Okay, so these are the two fields, and the one field is remaining is the protocol field. So actually the protocol field, that is this one, this field, the protocol. So protocol field actually tell you what type of the payload you are carrying. Protocol field will tell you about the payload in the IP header. Means what is the item that's being carried out in your IPv4 packet. What is the protocol? It can be the layer 3, it can be the layer 4. For example, if you will do the layer 3, it can be the EIGRP, it can be the OSPF, it can be the ICMP. And the layer 4, they are the two popular. One is the TCP and another one is the UDP. For example, if TCP is going to be there, the value will be 6. If UDP is going to there, the value will be 17. That is a protocol number. So if you will see the packet, let's see the protocol field. See, the value is 89. That is the value, the protocol number you you read when you were studying about the OSPF protocol. That OSPF protocol has a unique protocol number of 89. And if we see about the EIGRP, you will got to know that the here the protocol field. So here is the protocol field having the value of 88. Okay, and as we all know, the EIGRP has a protocol number of 88, OSPF has the 89, ICMP has the 1. So actually from this protocol field, the value of these will determine what type of payload you are carrying. So actually we have this is the first video of our channel. We are creating our channel for the network enthusiast, and if you can also visit our site, the UniNets.com. We give the training on various fields of the various networking courses. You can go through our site, and I will really appreciate if you gonna subscribe our channel. Thank you.